Hi all, welcome back to software engineering course. Let's get started. So today we will be starting with the fifth chapter, that is coding and testing, and here is your marks split up for the chapter. Okay, we get started now. So this is the agenda, that is in coding we will learn these all things like the basic programming principles and guidelines, how to incrementally develop a code, how to manage your evolving code, unit testing, and code inspections. These things we will study in coding, and after that we will start with the testing part. Okay. So the first one, what is coding? So in the last chapters we had seen that our process it started with the requirement analysis, then the architecture was done, designing was done. Now it is the coding process. Your coding is the activity to implement the design in a best possible manner. You have to code, like you have a design which is ready, then you have to start writing of the code such that you have to implement the design in a best possible manner. So now we will understand some of the basic concepts in coding. So the time spent on this, coding, it is a small percentage of your total software cost because your testing and maintenance will cost the or consume the major portion. Your testing basically it will take more time. Okay, so during coding, it should be kept in mind that the programmer they have to write the program in such a way that it is not easier to write or easier for them to understand, but they have to write the code in such a manner that it is easier to read and understand by other people. Now, why they have given a condition like this one? Like the developer, he will develop the code according to his mind, right? Whatever comes to his mind, he will have the variable names and he will construct the code. But they are saying like you have to, as a developer, you have to write the code which is easier to read and understand by the other people. This comes into picture because, say, suppose we have a project and you are assigned a developer for it. So, for the entire project, you might be there, or say you have worked till only the or till for the half of the project and you left the company. Then some other developer will come and he will start, using your code and he will improvise or he will add some other contents to that code. So, if you have written the code in such a way that it is very difficult to understand or the developer who has come he has newly joined the team, he might not understand what variables have you used or for what purpose you have used those functions or variables. So it is always best to write the code or use the variables method such that it is easier for others to understand, right? Okay, so again, the program is read a lot more often and by a lot of more people during the later phases. This I have already explained by taking an example. Now, if the programmers have specified a clear objective for the program, they usually satisfy it. So, what does this mean? So, we will consider an example wherein a famous experimental experiment was conducted by Winberg that showed the programmers, if the programmers or the developers have specified a clear objective of the program, they will usually satisfy it. So in that experiment, what it did was five different teams were identified and they were given the same problem for which they had to develop the programs. Okay, now, but these five teams were given a different objective which they had to specify. Like one team was given the objective to minimize the time required to complete the program. The other team was given an objective that is to minimize the number of statements, that is the lines of code. The other team was given to minimize the memory required. The fourth team was given the objective as maximize the program clarity, and the other one was given maximize the output clarity. So it was found that in most cases each team did the best for the objective that was specified to them. The experiment it clearly shows that if the objectives are clear, programmers tend to achieve that objective. Hence, if readability is an objective of the coding activity, then it is likely that programmers will develop easily understandable programs. Getting it? Next, we will see what are the goals of coding. So the goal during the coding, it should not be that to reduce the implementation cost, but the goal should be to reduce the cost of testing and maintenance. Now this goal how can be achieved, right? So it says the goal should not be to reduce the implementation cost or development cost. It should reduce the testing and maintenance cost. How we can achieve this is by doing proper unit testing, or having whatever they have mentioned in the SRS, by implementing the functional requirements properly, and having minimizing the bugs or finding of the bugs in the coding stage itself, so that your testing and the maintenance cost would be minimal. Okay. Next, we will see the programming principles and guidelines. The main task before a programmer or the developer is to write the code quickly and in a manner such that it should be easily readable and it should have few bugs in it. Okay, so whenever a developer is developing a code, he has to develop in such a manner that he or she should write it quickly, it should have minimal bugs, and the code should be readable. Now, how can this be done? So, this writing of the solid code, it is a skill. It only comes by the practice. Again, based on experience also, some general rules and guidelines can be given for the programmer. Good programming, that is producing correct and simple programming programs, is a practice independent of the target programming language. So it doesn't depend on the programming language which you are using, but only how to produce the good programs. It comes by practice. Although your well-structured programming languages makes the programmer's job simpler. So we have some IDEs, right? So they will give you. So if you start typing something like print, so it would give you the syntax of that one. So this makes the developer's job simpler. So we will discuss some of the concepts and practices that can help a programmer to write higher quality code that is also easier to understand. The first one what we study is the structured programming. Okay, so the basic objective of the coding activity is to produce the programs that are easy to understand. It has been argued by many that the structured programming practice helps to develop the programs that are easier to understand. Yeah, structured programming, this movement, it started in 1970s, and it has been much, it is said and written about it. So now the concept, it pervades so much that it is generally accepted, even implied, that the programming should be structured. Yeah, structured programming is often it is regarded as go-to-less programming. Although extensive use of the go-tos is certainly not desirable, structured programs can be written with the use of go-tos. So, a program that has a static structure as well as a dynamic structure. The static structure is a structure of the text of the program, which is just a linear organization of the statements of the program. The dynamic structure of the program is the sequence of statements that are executed during the execution of the program. So, in other words, both the static and the dynamic structure behavior are the sequences of the statements, while the sequence representing the static structure of the code, it remains fixed, while the sequence of statements it executes can change from execution to execution. Okay, the goal of the structure programming is to ensure that the static structure and the dynamic structures are the same. Getting it? The real motivation for structured programming is the formal verification of programs. That is, to show that the program is correct, we need to show that when the program is executed, its behavior is what is expected. For specifying the behavior, we need to specify the conditions the output of the program should satisfy. As a program will usually not operate on an arbitrary set of input data and may produce valid results for the same range of inputs. So we generally need to also state the input conditions in which the program is to be invoked and for which the program is expected to produce the valid results. Okay, so that is nothing but the post condition and precondition of the programs. So you cannot write a meaningful program without the use of branching or repetition. So the objective of linearizing, so how can we achieve the objective of linearizing the control flow? The answer here is by making use of structured constructs. Okay, so in this structured programming, a statement is not as a simple assignment statement, but it is a structured statement. The key property of the structured statement is that it will have a single entry and a single exit. That is, during the execution of your structured statement, it starts from one defined point and the execution terminates at the another defined point. With single entry and single exit statement, we can view the program as a sequence of structured statements. And if all the statements are structured statements, then during the execution, the sequence of the execution of these statements will be the same as the sequence of the program text. So, by using your single entry and single exit statements, the correspondence between the static and the dynamic structures can be obtained. So, the example here is this one, right? Selection, if B then S1, it should be S1, okay, else S2, if B then S1. So there is an iteration over here. So after that you have sequencing, whether it's S1, S2, S3 or whatever it is. Okay. Now it is the three basic constructs. It is your selection, iteration, and sequencing. These basic constructs are sufficient to program any of the algorithm. So your modern languages have other such constructs that may help linearizing the flow of control of a program, which makes it easier to understand the program. So your programs should be written so that as far as possible it should have single entry, single exit control structures, controls constructs. Okay, the basic goal we have tried to emphasize is that to make the logic of the program it is simple to understand. Getting it? Next we will study about information hiding. A software solution to a problem, it always contains the data structures that are meant to represent the information in the problem domain. That means when a software is developed to solve a problem, the software uses some of the data structures to capture the information about the problem domain. So, only certain operations are performed on some information. That is, a piece of information in the problem domain. It is used in a limited number of ways in the problem domain. For example, if you consider a ledger in an accountant's office, so it has some very defined uses like the debit, credit, checking of the current balance, etc. So, an operation where all the debits are multiplied together, then they are divided by the sum of all credits is typically not performed. So, any information in the problem domain which typically has a small number of defined operations performed on it. So, when the information is represented as data structures, the same principle should be applied and only some defined operation should be performed on the data structures. So, it is essential that this is the principle of your information hiding. The information captured in the data structures should be hidden from the rest of the system, and only the access functions on the data structures that represent the operations performed on the information should be visible. That means when the information is captured in the data structures and then on the data structures that represent some information. For each information on the sorry, for each operation on the information, an access function should be provided. And as the rest of the system is the problem domain, it only performs these defined operations on the information. And rest of the modules in the software should only use these access functions to access and manipulate the data structures. So your information hiding can reduce the coupling between the modules and make the system more maintainable. That means your information hiding is effective tool for managing the complexity of developing the software. By using information hiding, we have separated the concern of managing the data from the concern of using the data to produce some desired results. So our old languages, such as Pascal, C, Fortran, they do not provide mechanism to support the data abstraction. By using these languages, if you want to have the data abstraction, you should be having, some disciplined use of the language. That is, your access restriction should be imposed by the programmers if the language does not support them. But The object-oriented languages, they provide mechanisms to implement the information hiding. Now let us study some of the programming practices. So whenever you, if you are a developer, whenever you try to develop a code, what are the things you have to keep in mind while while doing development? So these are some of the basic programming practices, good programming practices. The first one is control constructs. Okay, so as discussed earlier, so it is desirable that as much as possible we should have a single entry and single exit constructs. So it is desirable to use a few standard control constructs rather than using a wide variety of constructs just because they are available in the language. Okay, so the next one is gotos. Your gotos should be used in a minimal way and in a disciplined manner. So only when the alternative to use go-tos is more complex, then in that time you can use a go-to. So in any case, the alternatives must be thought of before finally using a go-to. That means if you have any alternative to go-to, right? Try to make use of them instead of these go-tos. If you think that alternative is too complex and cannot be implemented, then only make use of these go-tos. So if a go-to must be used, then a forward transfer, that is a jump to or a later statement, is more acceptable than a backward jump. Getting it? Right? The next one is information hiding. So your information hiding should be supported wherever it is possible. Only the access functions for the data structures should be made visible, and you should hide the data structure behind these functions. So use for increase the cohesion. The next one is user defined types. So modern languages allow the user to define the types that are enumerated types. Okay. So when such facilities are available, they should be used wherever it is applicable. For example, when working with the dates, a type can be defined for the day of the week. Using such type, it makes the program much clearer than defining the codes for each day and then working with the codes. The next one is nesting. So if nesting of if then else constructs it becomes too deep, then the logic becomes harder to understand. In case of deeply nested if then else's, it is often difficult to determine the if statement to which a particular else clause is associated. So whenever it is possible, the deep nesting should be avoided. So here is an example for this one. So it says if C1 then yes1, else if C2 then yes2. So it has been continued till 4 levels. You might have another 6 levels also. So what we are saying is it is a good practice to not to use the deep nesting like this one. Instead of that, what you can use, you can have multiple if statements such as if C1 then yes1, if C2 then yes2, if C3 then yes3, likewise. Okay. Next is the module size. So we had discussed this issue in the system design. The programmer should carefully examine any function with too many statements, say more than 100 statements. So the large modules often will not be functionally cohesive. So there can be no hard and fast rule that about the module sizes. The guiding principle here should be the cohesion and the coupling for the module sizes. Next is the module interface. A module with a complex interface should be carefully examined. So as a thumb rule, any module whose interface has more than 5 parameters, this should be carefully examined and broken into multiple modules with simpler interfaces if possible. Okay. The next one is robustness. A program is robust if it does something planned even for the exceptional conditions. A program might encounter some exceptional conditions in such forms as like your incorrect input, the incorrect value of some variable, or it may be overflow. So if such situations arise, then the program should not just say like crash or code dump. It should produce some meaningful message that exit gracefully. Okay. The next one is the switch case with default. So you already know how to use this switch cases, right? So if there is no default case in a switch statement, the behavior can be unpredictable. if that can if that arises at some point of time which was not predictable at the development stage. So such it is a not good practice to use a switch case without the default. So such practice can result in a bug like null dereference, memory leak, as well as other types of serious bugs. So it is always better practice to include the default case with the switch statements. Next is empty catch block. You might know how to use a try and catch block, right? Whenever the exception is caught, but if there is no action, right, it may represent a scenario where some of the operations can be done, but it is not performed. So, whenever the exceptions are caught, it is a good practice to take some default action, even if just printing the error message could be better. The next one is empty if and while statement. A condition is checked, but nothing is done based on the check. What will happen in this case? Therefore, it often occurs due to some mistake and it should be caught. So other similar errors include empty finally, empty try block, synchronized, empathy static method, etc. Not empathy, sorry, it is empty static method, etc. So such useless checks should be avoided in the system. Next is side effects. Okay, I'll first finish off this one. Side effects. Okay, so when a module is invoked, it sometimes has the side effects of modifying the program state beyond the modification of the programs that is listed in a module interface definition. For example, modifying the global variables. So such side effects should be avoided where possible, wherever it is possible. And if a module has side effects, they should be properly documented. So you have to have the extra care when you are, modifying the existing contents or variables. The next one we'll consider is the read return to be checked. So the return value from the read is not checked, assuming that the read returns are desired values. So sometimes the result from the read can different from what is expected, and this can cause failures later. So there are many such cases where neglecting this condition may result in some serious issues. For example, if you read something from scanf, it is expected that it may cause a buffer overflow. So hence the value of the read should be checked before accessing the data read. The next one is read return to be checked. So one should not return from finally blocked as it can relate a false beliefs. So if we considered an example like we have tried, it got it throws some exception, catch will again catches the exception, and finally block it will say it has returned some value. So in this example the value returned both in the exception and in the non-exception scenarios. So at a caller side the user will not be able to distinguish between the two, that is which is the exception and which is non-exception scenario. So we should use something like this. Next one is the trusted data sources. So the counter checks should be made before accessing the input data, particularly if the data is being provided by the user or it is obtained over the network. Okay. For example, while doing the string copy operation, we should check that the source string is null terminated or that the size is as whatever we have expected. So similar is the case with the network data, which may be sniffed and prone to some modifications or corrections. So to avoid these changes, we should put some extra checks like the parity checks, hashes, etc. to ensure that the validity of the incoming data. Okay. Okay, there are two more which are not mentioned here. So the next one is correlated parameters. So often there is a relation between the parameters of any function. Okay, so before using before using these parameters directly, we should understand what is the relationship between the parameters you have sent to that particular function. The last one is giving importance to exceptions. So the most programmers what they do is like they tend to give less attention to the possible exceptional cases, and they tend to work on the main flow of the events control and the data. So the main work is it is done in the main path. It is the exceptional paths that often cause the software system to fail. To make a software system more reliable, the programmer should consider all the possibilities and write suitable exceptional handlers to prevent failures or loss when such situations occur. So now these two slides, whatever you can see here, these are the some good programming practices. Okay, whenever you develop something, you are a developer, you should have all these things, whatever we discussed now. Well, next we will have a quiz. The question is okay, say true or false. Using deep nested if then else is one of the best programming practices. You have to tell whether the statement is true or false. That is, using nested if then deep nested if then else is one of the best programming practices. You have got a minute of time to respond. Okay, time up. That's it for today. We'll conclude our session. Thank you.